January 2017, Unit 1. The first question, which of the following expresses the joule in the base unit? So basically, joule is a unit of energy, or we can say work done. And what is work done? Work done is force into distance. So force is Newton and distance is meter. What about Newton? Newton itself, because F is equals to ma. So Newton itself is kilogram meter per second square. So in place of Newton, we can write kilogram meter per second square multiplied by meter. So it will be kilogram meter square by second square. When we simplify, it should be kilogram meter square second raised to power minus 2. So kilogram meter square second raised to power minus 2. So option D will be the right answer. The next, select the graph which correctly shows a variation of kinetic energy with the speed. So the kinetic energy is equals to half mv square. So what is the relation between the kinetic energy and the speed square? They are proportion with square. So it means if the speed is double, the kinetic energy will increase by 4. If its speed is triple, like speed increases by 3, kinetic energy increases by 9. So first thing, that proportion with square, not directly proportional, but proportion with square. So what it should be, if it is directly proportional, like if the relation, the kinetic energy is proportional to V, then this should be the answer. This is not showing any relation. It's called a linear relation, but not directly or inverse. Again, this one also does not show a relation here. Option D, when we double the speed, kinetic energy will be 4. When we triple the speed, kinetic energy will be 9 times. So that's why D is the right answer. Block of mass M is placed on a bench and a horizontal force F is applied on a block. The block accelerates along the bench in a travel distance d and time t, reaches a velocity v. What is the work done? So there is a block which is placed on a bench horizontal. So say for example, this is a block and it is placed on the horizontal bench. So there is a mass is m, the force applied is F, the distance moved is d, the speed at this point is v, the time taken is t. How to calculate a work done on the block? So the formula for work done is force multiplied by distance. So we have the force and the distance moved. When we multiply, we'll get the work done. So option A is the right answer. This question, to travel from position A to position B, a car drives 20 kilometers east and then south. We have to find, select the row from a table correctly expresses the magnetic total distance. So total distance means total length covered. So first it to move 20 meters, then 20 meters. So what is the total length covered? The total length covered is equals to 40 kilometers. But what about the displacement? Displacement is the shortest distance between the 2 points. So the shortest distance between A and B is this one, which is a hypotenuse according to right angle triangle. So if we have a right angle triangle, that hypotenuse square, according to Pythagoras theorem, hypotenuse square is equals to base square plus perpendicular square. Or hypotenuse is equals to under root base square plus perpendicular square. So it will be square root or under root 20 square plus 20 square. So under root 20 square plus 20 square will give us the displacement. But the total length which is covered, like from the starting point, what length is covered, that will give us the distance travel. So distance travel is 40 and displacement is under root 20 square plus 20 square. Next, Two groups of students were asked to perform an experiment to determine the acceleration due to gravity or acceleration of a free fall. Each group repeated their experiment 3 times to check their results. In each experiment, a steel ball fell through a height which is just under 1 meter. Time for the ball to fall was measured. Group 1 used a stopwatch to measure, and Group 2 used a light gates connected to a data logger. Then student measure the height fell using a meter rule, meter scale. The height should be recorded as, so it's a meter scale. As you can see, 1 meter long. So we should be reliable, like the most reliable result. Like if we have more significant figure, we'll have more reliable result. Whenever we are using a meter rule or a meter scale, it should be like 3 significant figures. So which one measure approximately 3 significant figures? This is 85 centimeters, so not correct, 2 significant figure. Because the meter rule or a meter scale can measure to 3. Like example, if it is measuring, say, a meter rule is 100 centimeter, or we can also say 1 meter. So we should be, to get the more reliable result, what is the accuracy? The best it can measure to 3 significant figures. So this is 2, this is 2, and this is also 2 significant figures. So C is the right answer, that it can measure to 3 significant figures. So remember, whenever we are using a meter rule or a meter scale, it can measure to 3 significant figure. Accurately the answer to 3 significant figure. Then in question 6, select a row from a table, correctly describe the reliability and validity. So whether the results are reliable, look, the first group is using a stopwatch. So stopwatch, it won't be reliable, like, because there's a chance the error is there, that reaction time of a person, that it may lead, it won't be reliable. Like we cannot say that is reliable result because it is having some errors. So group 1 won't be reliable, but valid result will be valid. Like we can use it to determine the acceleration due to gravity. Like it's not like it will give us totally wrong result, but it won't be reliable. And when we check for the second one, the second group is using a light gate. So it will measure accurately. So result will be reliable as well as valid. So C will be the right answer. Then another question, an object is there which is having a volume of 2.4 into 10 to the power minus 5 meter cube, was suspended using a spring balance in air and weight in Newton. The object was then placed in a measuring cylinder containing a water of a density 1000. The reading on the spring balance. So how we can work out the reading on the spring balance? Basically, when we put the object inside a liquid, a container which is filled with a liquid, so there is a force exerted, like outside there was only the force which was acting, that is equals to weight. But when we immerse this object inside, the object is placed inside, so weight of the object will act downward. So weight is acting downward, and upthrust, the reaction force of a surface will act upward. So how much the reading on the balance? Because first, when it was a spring balance was connected, so the force here was equals to weight of the object. But here, the force on the spring balance will be W minus U, means it will decrease by upthrust, or the total weight minus the upthrust that will be the reading on the spring balance. So the question is the reading on the spring balance. What happened first? C and D cannot be an answer because it won't increase, it will decrease. How much it decreases? That it decreases by upthrust. And how to calculate the upthrust? The reaction force of the fluid, that is density of the fluid multiplied by volume of object multiplied by gravity. So what about the density of a fluid? Because as they mentioned here, we are using a water which is having a density of 1000. So this is 1000 times the volume of object, which is 2.4 into 10 to the power minus 5 multiplied by gravity 10. So when we multiply all of them, we will get the upthrust. So weight minus the upthrust. So weight minus the upthrust. So which factor is giving the upthrust? So density, volume, and gravity, or volume, density, gravity. This will give us upthrust. So upthrust minus the weight, that will be the reading on the spring balance. So B is the right answer for this. A uniform rod is found to balance when a pivot is placed. So this is when this use the term uniform, it means its center of the mass is acting at the center. But now the rod is replaced from one material, two different materials. The right hand half of new rod is double the density and half the diameter. Where should be the pivot in order to balance now? So where we should place a pivot? Here is density is higher. Both have the same length. Basically, for first one, the mass was evenly distributed. The mass on the right hand side and the mass on the left hand side was evenly distributed. That's why the center of the mass was there at the center. But now we have to check if both have the same length. So what will be the mass here? Density is equals to mass over volume. So mass is equals to density multiplied by volume. And for this side also, mass is equals to density into volume. They mention the rod is replaced by one from a two different material. The right hand half of a rod of a new rod has a double the density, so its density is twice. But half the diameter. So if we halve the diameter, what will happen to area? Because volume is equals to area multiplied by height, and area of cross section is equals to pi r square. So if radius is half, diameter is half, or radius is half, so what happened to area? Area will decrease by 4. So area will decrease by 4 if area decreases by 4. If area is decreased by 4, volume will also decrease by 4. So volume here will be V by 4. So when we simplify, it will be density volume divided by 4, or we can say mass divided by density, like 2 density volume divided by 4, or when we simplify density to volume divided by 2. So means on the right hand side, the mass will be m by 2, and the left hand side, the mass is m. So because more mass is there on the left hand side, so what will happen to the center of the gravity? That will shift towards left hand side. So to the left of the O, the new position of the center of the gravity. If we get the equal mass, then the center of the gravity will remain at the center. So how we relate? Because area and diameter, or area and radius, are area is equals to pi r square. So if diameter is half, radius will be half. If radius is half, area will decrease by 4. And if area is decreased by 4, the volume will also decrease by 4. And according to mass, density into volume, if volume decreases by 4, density is double. So total change in the mass is density into volume divided by 2, or m by 2. So right hand side is m by 2, left hand side is m. So what will happen? It will have more mass on the left hand side. As a result, it will have center of the gravity on the left hand side. So center of the gravity shifted according to the distribution of the mass. Concrete is used in both spans and support column. As you can see, the spans are shown here and the support column. So we are using concrete in both. The spans needed to be reinforced with a steel, but support columns do not. So support column does not need a reinforcement, but the spans need a reinforcement. This is because concrete is when we check so as they mentioned here, the span need to be reinforced with a steel, but the support column do not. Like support column do not need a reinforcement. So what is the reason for that? This is because concrete is like here, these support columns, we need a steel. But here, sorry, in the span, sorry, we need a steel. According to question, the span, we need a steel. But in a support column, we don't need a steel. So what is the reason for that? Means here concrete is strong. Support column concrete is strong. But in a span, when we are using as a span, concrete is weak. So what happened in a support columns? In a support column, there is a force on the support column, but that force is not able to break this concrete or crack on this concrete. So we can say concrete is strong under compression. That's why it does not need a steel. Because if you see these support columns, there is a weight acting downward, and due to the weight acting downward, there will be a force downward. So it will experience a compression. But because we don't need steel for this, so it shows that concrete is strong under compression. And tension refers to a stretching. Like example, so there will be a force on the supports. We need a steel reinforcement for this. Without reinforcement, the bridge will collapse. So what it shows about the nature of a concrete, it shows that it is weak under tension. Like when there is a tension means when the direction of the force is to stretch, and compression means when the direction of the force is to reduce the size. So concrete is strong under compression and it is weak under tension. That's why in a support column, we don't need reinforcement, but in a spans, we need a reinforcement of a steel. That's why D is the right answer for this. Then in question 10, 1.8 kilogram mass is suspended from one end of the spring. The original length of a spring was 0.04. The spring stretches 3 times the original length. Like if it was 0.04 originally, then it becomes 3 times the original length, so 0.12. Because now they mentioned it is 3 times the original length. If original length is 0.04, 3 times of 0.04 is 0.12. What is the work done? How much energy transformed? So work done or energy transformed is equals to half force into extension. So half. What about the force? If we add 1.8 kilogram, so 1.8 kilogram is not the force, that is a mass. So force is the weight. So how to calculate the weight? 1.8 multiplied by 9.81. In A levels, the gravity is because weight is a force, weight is mass multiplied by gravity. So 1.8 multiplied by 9.81 will give us how much force it will experience. So that is 1.8 into 9.81. And what about the extension? Extension means increase in length from the original. So how much new length is 3 times the first original length, but how much is extension? So extension is twice, so extension is 0.08. Like total length minus the original length will give us extension. So 0.08. When we multiply these, half force into extension, so this will give us 0.71 joules, or C will be the right answer.